Alright, in this series of videos, I'm going to go over some counting techniques. And this isn't like the preschool counting 1, 2, 3, 10, 11, 12. The counting I'm talking about here is counting you would see in high school, maybe early college, for how to count large numbers of things, coming up with a systematic way to figure out how many things can happen. For example, if in playing poker, how many ways can you get a full house, and that sort of counting there, and that's something that we will consider farther down the road. These videos are going to be loosely following the first chapter from a book that I used in college, Discrete and Combinatorial Mathematics by Dr. Grimaldi. I also had him as a teacher in college. I'll include information on that book in the description down below. So, first, a brief outline of what the videos are going to cover. In this first video, I'm going to cover some basics, and these basics are things that students may already cover or master in junior high or early high school. And then from there, talk about factorial, which would be a sort of high school thing, permutations, combinations, and try to go a little bit deeper with these, make sure that everything is completely understood, and then sort of some special, little tricky thing with the combination with repetition, and a little exploration of Catalan numbers. So let's start off with these basics. When we're counting things up, sometimes we add, sometimes we multiply. And so, when to add? Well, I like to say that this addition usually comes from the word or. And so, very specifically, if you are doing one thing, you are like picking one card, picking one marble, rolling one die, coming up with one number, that can be split into two, or possibly more, but I'm just write two here, two separate ways. That might be misspelled. We can find out how many ways that happens by adding the number in each of those ways. So we can add to find out the total number of ways it can occur. Okay, so add usually goes to or. Here's an example. So we'll consider the integers from 1 to 10. And I want to know in how many ways I can select a number that's either a prime number or a multiple of 4. So I'll start off, I'll write out the integers from 1 to 10. Just list them all off. I'll put it in set notation, but you could just write a list and still solve it equally well. Okay, so in this, we have a single thing happening. We're picking one number, but we're splitting into two separate, disjoint groups. Prime, I guess I'll just underline prime, or multiple of 4. So in here, our primes are 2, 3, 5, 7. I'll write those out. Our multiples of 4, in this case, are just 4 and 8. And this leads us to this either or case having a total of these 4 and these 2, 6 possible things. We can have 2, 3, 4, 5, 7, and 8. So in here, the idea was we have completely separate. There is no prime number in here that is also a multiple of 4. There are no prime numbers that are multiples of 4 because 4 is composite itself. The number of prime numbers, the number of ways I can get a prime, is 6. The number of ways I can get a multiple of 4 in here is 2. And so the number of ways to get a prime or a multiple of 4 is 8. Oh, messing up, sorry. Not 6. 4 primes. 2 multiples of 4. Jumped ahead of myself there. 6 total elements. 2 is prime, 3 is prime, 4 is multiple of 4, 5 is prime, 7 is prime, 8 is a multiple of 4. So this is a case where we would add. So when do we multiply? Multiply, I like to sort of connect to the word and. So, and this multiplication happens when we have, when we're really doing this in sort of 2 or more steps or stages. So if you have these 2 sort of steps, you can multiply the number of ways for step 1 to occur to the number of ways for step 2 to occur. So the difference is, in the multiply we're saying I want to do this or this. You're only really doing this sort of one thing and it comes from 2 sets. In further addition, for multiplication I have 2 steps. I'm going to do this thing and then I'm going to do this thing, and so I'll multiply that out. And so let's look at a similar problem to that previous one, but now instead of just pulling one number that can be from one or the other, I am going to pull 2 numbers, so from the integers 1 to 10. I will first select a prime, and second select a multiple of 4. So my integers from 1 to 10, well, same as 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The primes we had are still the same primes, 2, 3, 5, and 7. And the number of multiples of 4 are 4 and 8. And in here, to figure this out, there are a couple of ways. So I could just list it off. So first I'm picking a prime, then I'm picking a multiple of 4, and I'll just sort of write that out kind of quickly. Those elements are going to be these. We pick 2 and then 4, or we pick 2 and then 8. We pick 3 and then 4, or we pick 3 and then 8. We pick 5 and then 4, or we pick 5 and then 8, or we pick 7 and 4, or we pick 7 and 8. And you can see here, I have this set of ordered pairs. There's a first and there's a second in an ordered pair. The magnitude of these primes, there were 4 of them. The magnitude of the second containing the multiple of 4 was 2. And the magnitude of this sort of cross product of this set and this set is 8. So 4 times 2 equals that 8. Now, a little more understanding here, so I don't like just looking at multiply, get an answer. Other ways to view this. You can think of it this way. We're picking one number first out of this, so I start off with picking one of 4 things, either 2, 3, 5, or 7. And then from each of those 4, I pick one of these 2. So I pick a 2 and then I either pick a 4 or an 8. I pick a 3, then I either pick a 4 or an 8. Pick a 5, then I either pick a 4 or an 8. And I pick 7, and then a 4 or an 8. So you can look at it this way, where the first step, I have a choice of 4 things. And then the second step, from each of those 4 things, I have a choice of 2 things. You see I have sort of 8 possible leaves here, 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, where a single one of these outcomes is sort of the path you take. It is, for this one here, first picking a 3, then picking an 8. I could also represent this as a two-way table where I pick my first number, either 2, 3, 5, 7. That's not a 7. 7. And then I pick a multiple of 4 for 8. And in here, I'll just put little dots, but we have 8 possible outcomes. We picked a 2 and then a 4, 2 and then an 8. This means like 5 and then 8. And again, the same idea. I have this sort of area that is 4 by 2, and the area that's going to be 4 times 2. So you can see with this, and we end up with either branching trees or areas, which would lead us to that final 4 times 2 equals 8. Alright, the next video I'll just go through a few examples of this to make sure we've got it all down pat.